Welcome back everyone. We're going to be looking at how we can find the Cartesian equation of a plane. In the previous video, we found the parametric form of the plane, but now we're going to convert that into its slightly different form called Cartesian. Cartesian form means you're going to have one equation in terms of x, y, and z, whereas previously we had a parametric equation, which meant in effect we had three equations. Equation for x, which would be 2 minus lambda plus mu, an equation for y, which would be 1 plus 2 lambda minus mu, and an equation for z, which would be 3 plus lambda plus mu. So our parametric equation meant we had three different equations, one equation for x, one equation for y, one equation for z, and those equations, each of those equations we've written in terms of the two variables lambda and mu. In our Cartesian form, we're going to have one equation that is written in terms of x, y, and z. You're going to need to know how to do the cross product for this video. So if you don't know how to do that, I'm going to recommend you watch our video on this before. So I'm going to start by looking again at our diagram. This was what our equation of the plane looked like. Okay. Now it's important to know that if I do the cross product, I'm going to find a third vector that is perpendicular to these two vectors. So imagine that my plane is currently looking like this. We've got the vector 2, 1, 3 that takes us to the point 2, 1, 3, and then we can kind of imagine that that is our plane here. Okay, imagine that's what our plane looks like. And we know that the plane is generated by multiples of these two vectors. Okay, so I'm just going to draw these two vectors here and here. Okay. Now, if we take the cross product of these two vectors, we're going to have a third vector, okay, that's going to be perpendicular to both of those, okay? It's going to be perpendicular to minus 1, 2, 1, and it's also going to be perpendicular to 1, minus 1, 1. I'm going to call that n for normal, okay? So this vector is going to be perpendicular to this whole plane, okay? There's going to be a right angle. So if you imagine the plane like a piece of paper, we talked about that before, this would be sticking out at a 90-degree angle. So let's use the cross product to find the equation of the vector n. So there's a few different ways of finding the cross product. I'm going to keep this in purple to match my diagram, but this is the way I like to do it. I write the vectors in here, minus 1, 2, 1, add a couple of extra columns, minus 1, 2, and I put the vectors inside like this. Oh, careful you don't make any sign mistakes. 1, minus 1, 1, 1, minus 1. So check all your signs, minus 1, 2, 1, minus 1, 2, 1, minus 1, 2, 1, minus 1, 1, 1, minus 1. So right now we're doing the cross product to find the vector that's perpendicular to both of these. Okay, so when I go this way, I'm going to have a positive sign. So this is going to be I times 2 times 1, so it's going to be 2i. Then I'm going to move along here. J times 1 is 1j.